Hi folks, welcome back. This was a $7,000 mistake. Today's video I'm going to take you through it. I've turned it around and got power to it so we can see what's wrong with it and why I probably would have never bought it in the first place. The backstory. 5 years ago, a friend of mine purchased this online, sight unseen, from an auction. He bought it, rented a truck, rented a trailer, came to Houston, picked it up, and brought it over to my shop where we were going to have a scraping class. He wanted to check it out and make sure everything was okay before he took it home to Austin. I was pretty busy during scraping class. I usually plane a lot of straight edges for the students, and I was not really paying attention to what was going on with this. I ran them some power over to it, and over the course of about 4 days, I saw some pretty sad faces. I kind of got interested then and went over and looked at it. This is a Monarch 10EE, arguably the most finest, precise tool room lathes ever made. You can still buy a new one today. I think they're $168,000. And it's probably better called a remanufactured by Monarch. They go around looking for good casing or castings because they just don't cast them anymore. And then they bring it all back to factory specs. And there are some doozy of factory specs. This isn't a South Bend. This isn't the old clapped out lathe you find just about everywhere nowadays. This machine, I forget the run out, and I may be wrong, but it sticks in my head that 50 millionths run out on the spindle. I have to look it up, but that's what I remember. Precision bearings in the head. The bearing for the front alone costs $2,800. And it's got $1,500 worth of bearings in the back of the spindle. This was a world-class machine. Notice I said was. This is a little bit more rare than normal. This is also an inch metric machine, which just by changing some of the levers here, you can cut either metric or inch threads. I want to go around and show you kind of what we found and what it's going to take to get this back to where, close to where it was. It'll never be the same, because frankly, it would take me years to make it the same, and I doubt if I could. I bought this from the current owner and tried to pay him as much money as I could for it. I am selling the blue lathe that we were going to remove the spindle from and put in this one. I'm probably not going to part it out. There's a young man that I've been kind of mentoring a little bit, and he knows full well the dangers of that lathe and that it's too easy to go in reverse. But with my help, he's willing to give it a shot at restoring it, which I think that'd be great. Now, let's go over some of the problems that we found with this lathe. First off, let's start with the headstock. Now, the headstock is this portion up here. This is a chuck guard that I believe is an original Monarch. Kind of got some screws out of it. That's easy to fix. It's got a bracket that is cast and fits perfectly on these ways. I believe that came from the factory. This is a D13 spindle. It has little locks right here that lock either a collet chuck or a regular chuck to the nose. In fact, Here is a collet chuck that goes in here. And then you take a collet wrench or a chuck wrench and you tighten up these screws. And these are little cams that go around. There's 3 of them. My 20-inch Axelson lathe has a D8, which has 8 studs sticking out. And then this is a collet spindle for C5. Problem is, this machine has been crashed, and crashed badly. We took this collet spindle off, or excuse me, this collet. I could see better. See where the lines are. It looks like it. Got a little line there that lines up on the top of it for the unlock position. And that comes off. Andy put a test bar in that collet and started turning it and found that something was wrong, real wrong. This spindle has been reground inside. They put a spindle on, a grinder on here, and they re-ground the outside of this. The reason I know they did was because the inside they didn't touch. And if you put an indicator on the inside, this is out of round by 0.02 of a. This is dead on accurate. The problem is when they ground this to make it accurate, they shortened the nose and thus the taper, and so none of the jaws or none of the chucks will fit on here right, and they wobble. To get over that, they put some lead tape in there and cranked it down as hard as they could, but it was still really out of kilter when you measured it. The reason it's like this is because somebody was running along and not minding what they were doing, and they crashed a workpiece or a chuck or something into the cross slide. And the reason I know they knocked it into the cross side is because this is a piece of base on that, and I don't know if you can see. Try and here, get you some light on it. Right there, there's a crack, and it goes down underneath that bed and comes out over here. They hit that cross slide so hard, it broke off that dovetail. It's still there, but it's not connected to the rest of it, and you can even feel how it ramps up when you go up there. We got to fix this. And I'm of 2 minds right now because it's such a small total area. I think I'm going to gouge this out and go back up underneath there and over here and TIG weld it with some easy TIG weld rod that I found. Now, I love that rod. You don't have to preheat or anything or control the heating afterwards. Some great stuff. But because this is just this one area, I'm hopeful that I can weld that back together, then grind it back down to where it works. Otherwise, I'm going to have to get a piece of Durabar and just make a whole new base. So I'm going to give the welding a shot there. You can see when they were working on it, we pulled off all of this mechanism so that we could see what was going on. We also scraped the bed of the vise and used it as a measuring platform along with a kingway to determine the wear on the bed. Now, remember, this is a precision bed, flame hardened ground. This is a newer model. This is a baby in Monarch terms. This is a 1990, born in 10th month of 1990. Most of the ones you see are 45s, 40s, 50s, 60s. This is kind of unique. It's got some wear on it. Right here on the flats there is minus 7 thousandths. Down here is minus 5 thousandths. Over here it's 0. And over here it's 3 thousandths. So I don't know how big of a problem it is, and I haven't seen the underside of the carriage, but I suspect it's worn too. Now here's some of the gears. A little backlash in this, not a whole bunch. There's not much you can do about it because it's gear to gear, small gear driving this gear. This is a kind of an oil filter that's all clogged up. And there's trash and stuff in there. This is going to have to come off. Just, it's this far along. I'm just going to take it on off. And when I do, I'm got a crazy idea to grind this bed in place. Now, the bed stops right in here. Are you watching? Here, come on. Get back out here. Now the bed starts right in here and goes to there. And you have to take off the headstock and you have to do all this stuff. Then it has to be ground. Well, I'm set up for planing. And I don't think my planer is going to touch this surface easily and nicely. You know, we're only taking off maybe 7 thousandths. So I have a grinding spindle and I'm thinking of a way to make it perfect out here without going through the mess of taking everything apart. Will it work? Who the heck knows? I'll give it a shot. Now this is the business end of the drive system. I've taken off the two covers here. In fact, I've taken the covers off the whole machine so we can look at it good. This machine has a 5 horsepower DC motor that's buried behind this gearbox. This gearbox has a high and low range, and you shift it from up here, and it's called belt drive and then called back gear drive. The output of all of this goes through this big pulley, and it's almost a 1-to-1 ratio. This one's a little bit smaller. This is a 3,500 RPM motor driving this lathe that has a speed of 4,000 RPMs. As you can imagine, that's fast for a manual lathe. It has 2 V-belts, matched V-belts that come from the bottom pulley down here, go around the top pulley. They have 2 idler belts right here, and these have aluminum. They're made of aluminum on the outside, and they have a little bit of wear in them. So we're going to be pulling that off, and I'm going to put these on the lathe and true that surface back up so it doesn't wear in anymore. The whole thing about this lathe is getting rid of vibration. So they designed it so you could have an almost flawless surface finish by using all the technology that they had. And this technology is still great today. This is another idler that goes for this back drive belt. This drive belt drives the gearbox. So you got 3 belts, 2 matched V belts and a 1-inch flat belt for the gearbox. This is the oiler for the gearbox. You can put oil in here. It's got a sight glass around the front. Now this gearbox has you add oil on the top and then it has a sight glass down the bottom. Well, whenever you buy an old machine, you're kind of stuck in that you don't know the history on that machine. I don't know if this gearbox has the correct oil in it, and I don't know if this gearbox has the right amount of oil because I can't see through the sight window down there. Luckily, this sight window is also the drain for the oil. So I'm going to put a wrench on it and pull it out and drain this unit so I can put the correct amount of the right oil in it. Same way with the head, same way with the gearbox. Who knows what they put in it? You know, this was a corporation owned this machine, and unfortunately people are involved that don't own the machine, and they just, oh, this will work, and they throw what they think can be okay. And they may have done the right oil. I don't know. That's the problem. I don't know. So I've gone through and just till we tear it down, have filled the spindle box and the gearbox with the correct oil. The apron's not connected. We'll get to that later. So the only thing I need to do now is drain the oil out of here and replace it. So that's the end of the drive section. This is a little brake so that it can lock the spindle so you can change chucks and things on it down there. And it's got an electrical interconnect. There's also another electrical interconnect right in here that's hidden behind this slide for the idler pulley. And it is a interlock that protects the gear train from going into back gear if the machine is turning over 200 RPMs. I don't know where it's getting its input for how fast it's going. But I did find that that's not working. And that plunger sticking out will inhibit you from going into back gear. So, more on that later. I mentioned earlier that this machine has a bent spindle. And several viewers say, oh, it doesn't have a bent spindle. All I know is this was all ground off, so it's made the spindle useless to me. It needs a new spindle so you can put on chucks properly. And if I ever want to put a collet closer through it, this ID is 0.02 off. So it's got to be fixed or it's useless. The other problem is, remember I said this was probably the most accurate tool room lathe ever made? And it's because of the relationship of the drive and the spindle and the bed. But the spindle uses some really expensive bearings right in here. And if this got hit hard enough to bend the spindle, break the crossfeed dovetail, and mess up other parts in that crossfeed, it took a heck of a blow to the bearings. There's 2 of them right here. They're $2,800 for them. You can't buy them anywhere but Monarch. They're custom made for them. Some people have, over the years, had some made, but I can't find any of those. Anyway, to me, this whole spindle needs to come out, even if it's just because the taper's messed up on this end. So, I've been investigating that. This, I'm going to show you the inside. It's got a little brass funnel under the oil fill, so when you pour oil into it, it funnels it out. Let's see if we can get closer. Now, it's pretty simple. The spindle goes all the way through this cavity, and it holds up this gear, a shifting fork, another gear up here for the tachometer, and then there's a nut right here that you tighten up the bearings that are situated inside this housing. I have to make a new gasket. The back bearings are in this housing back here, and you can see that it has oil lines running everywhere. So, we then go outside. There's another, there's another sprocket, maybe is a good word, that engages the pin on this lock. Then you have this double belt, and then you get on down here in the spindle lock. To get this out, this lock will come off. Unscrew this, take the belts off, loosen up all the pulleys inside, and pull it out the nose. You loosen 6 bolts here, and then the whole cartridge and spindle comes out this way. Any questions? I have tons of them. Okay, to recap, I highly suspect these bearings took one heck of a wallop. They're really precision bearings, and if you hit the spindle this hard, I find it hard to believe that those bearings didn't take a heck of a hit too. This is no good. Got lots of work to do on the crossfeed. And now let's get to the other problems. If you remember, this basic lathe has been in production since 1939. Still buy one today. You got $168,000. Now the same basic casting has been around all this time, and they stuffed electronics or electrics for the old motor generators down in all these compartments. It was very well thought out. This compartment on this machine is totally empty. You put a beer keg or something in there. This compartment is also totally empty except for one little strip. This compartment holds the motor, and on the 1941 10EEs, that little hole down here on the bottom compartment, well, you can't see, you're too tall. That little compartment just below that red tag holds a whole bunch of electrics, and there's a big DC motor put in there that you got to adjust the brushes and everything. This ain't one of them. This is one of the more modern designs. Sorry for the extra noise. Had to turn on the phase converter. This machine is a modular machine. It's one of the latest drive systems they made. And it's much different from like a 41 model or any of the works in the drawers. They called them works in the drawers because everything was down in one of those compartments. And you just open it up and it came out on a little door. This has none of that. This has a big green cabinet on the back. It's got a pump, which is located in this back cavern, as opposed to the 1940 or 54 model that I have that's on the side in the back. This is a rheostat to control your reverse speed. This is for the pump. Let me turn on the power. This is for the pump. Well, first you got to hit the on. Pump works. I don't know if it's pumping, but it turns on. This is a stop button, and this is the button you push to start the electronics in motion. Now, this machine has a dial that goes up to 4,000 RPMs, and it's supposed to be able to do 4,000 RPMs as it came from the factory. I'm going to turn it on and put it in forward gear and show you what's going on. First, I'm going to put the oil back on because it's a pumping. Which is a good sign. But when the top's off, it doesn't work too good. Okay. See how long it took to spin up? Right now it's doing about 600 RPMs. Speed control still works on it. That's at maximum. Wait a minute. This is supposed to be over here. And watch this. Watch how fast it breaks. That was pretty anemic. It's like it has almost no braking at all. Now this is a DC drive motor that is a 4-quadrant, and it can go just as fast in reverse as forward, and the braking on a properly functional one is almost instantaneous. Something's wrong. This is only going 1,400 RPMs. It should be doing 4,000. It doesn't have any braking, and it's just weak as all get out starting it up. So, what do? You start digging. And that's where we found the last bit of the $7,000 mistake puzzle. Follow me. Now this is a modular control box for this machine. All the electronics are in this machine back here. It's got a door interlock. Has to come down to be open. I'm going to use a little camera so I can get in here and show you what's going on. Can you see? It's not pretty. This is the control panel for this machine. These are big breakers that will not turn on the machine if the door's open because of this interlock right there. A contactor up there, another set of three-phase. The crappiest wiring job I've seen. Heck, my grandmother could do better than this. She's been dead 30 years. Control wires run with the main lines going to the motor. There's only one place I even see any shielded cables. Somebody's been in here. These are two big transformers that the incoming power, which is 480 right now, is transformed down to 120 volts on each one, and then they combine the 120 volt output of each to make 240, goes through that little fuse box and up into this board. Now, there's also another 480 to 120 transformer that is providing the control voltage for the machine. You know what the problem is? Have you seen it yet? There it is. That drive has been put in place, and it's made by Baldor. But it's a rebadged K and B board in there, so it's made by K and B. And whoever thought that this would work in this machine was sadly mistaken. This board cannot control the field of the DC motor. It has outputs for field. You can go half, which would be 120, and you can go full, which would be 240. But it doesn't control the board. It just is there. So, what has to happen? This has to come out and a proper one put in its place. I can't afford a proper one from Monarch. So another gentleman and I, along with Don, who may not look like it, but he's an electronic engineer, we're going to be working on a new drive for this machine. And I'm going to clean up this mess. The drive may cost $3,000 for this thing. Hopefully we can get by with some used parts, but that's another reason this is a $7,000 mistake. For the back end of the machine, I've taken all the compartments loose. It's got some chips down there. This is the back end of the DC motor. Now on a 1954 motor out there, it's got a AC motor with a blower and a generator on this end, all designed to power that motor. This motor, it's just being taken care of by the electronics. While we're back here, one time this had a digital readout on it, DRO. Don't know if I'll ever put one on there. I don't need one much for what I do. You can see now what problems I'm facing resurrecting this lathe. And you can see why I call it the $7,000 mistake. It should have never been purchased for that amount of money. But that's what happens at an auction. And, you know, people look at things and they say, hey, I like that one. A 1990 10EE, wow, it must be great. Well, unfortunately, these things come from a manufacturing or tool room where not everyone takes good care of them. And this one would be doomed mainly because of the spindle and the drive. The drive's going to cost a lot of money to fix, and there's just no way around that. The spindle, if I had to buy a spindle for it, and the bearings especially, I just couldn't see it. Luckily, one of the viewers, Terry from British Columbia, was very generous and just happened to have this sitting on a shelf. I've been working on this today, cleaning it up. This is a 10EE spindle. I'm not really sure what year model it came out, but judging from what I see, everything's the same on there. Now this is the front section that you jack out, and the spindle comes out this way out of the nose. This is a bearing race, and here's another race. This is the special flange bearing that's got a flange on it. $2,800 for those two pieces. This is a separator, and then this nut, which on this one, both of the set screws are out. So I don't know if they've taken it out for what reason. That's how you set your preload on the spindle. So we're going to have to rob parts off of that one for here for locking it. And also one of the cam locks is worn out. And so we'll take out the cam locks of that one and see if they're any better. I mean, this part of that other spindle is shot. So hopefully this one fits in there. I'll TIG up this cast iron and then re-scrape it and grind it, get it back to the normal shape. And got a few extra things in case there's a problem in there. That's the tachometer gear. I spent a while polishing it up and buffing it and cleaning it today. Guys, I really, really, really love these little Milwaukee fuels. A friend of mine down in South Houston turned me on to this. For this, I just use a lamb's wool buffer. And believe me, they make all kinds of accessories, different pads and things for these things. It's my drawer. Y'all aren't even looking in the right place. That's my drawer of different pads and things you can use. Anywhere from really fine sandpaper to felt wheels, which is what I used on that, on up to some really aggressive pads. If you don't have one, get one. Those are great. You got a little drill adapter, and they've got a quarter-inch. That's all I have for right now. Going to be filming everything I do for this. Kind of wish it would just run, but none of the machines I ever get just run. So I'm used to that. We'll clean it up. I tried a little bit around these plaques. These are some nice plaques. Maybe we'll get old Don to put the black around them again and shine them up. The paint on this thing isn't the worst I've ever seen, but this isn't going to be a full tear down and restore. Around here, it's like the old cowboy saying, get her done. Most of the machines that come into my place, I make sure they work mechanically. I can live with the surface not being perfect up here. I don't like it, but it takes a lot of time. And when I get more time from being retired, then we can do stuff like that. But right now, I need this baby to work because I got a whole garage full of machines that we got to fix. Thanks for watching. And thanks again, Terry. I think it's going to work. I'll pull it tonight and we'll see.